Hello guys, welcome back. In today's video, we're going to discuss about the very first chapter of physical chemistry, which is energetics. Okay, so within any chemical reaction, there is always an energy change. Okay, energy can either be gained or energy can be lost in the form of heat, which means that something can become colder or something can become hotter. Now, if something becomes hotter, we call it an exothermic reaction. It is a reaction where your heat is released to the surroundings and hence your temperature will rise. An example reaction of the exothermic reactions are reaction between metals and acids, neutralization reaction, and displacement reaction. So endothermic reaction is the opposite of exothermic reaction. In endothermic reaction, heat is absorbed from the surroundings and hence the temperature is decreased, the mixture itself and the surrounding as well. Alright, so one example of endothermic reaction is thermal decomposition reaction. So try to understand that in an exothermic reaction, you're going to see light or you're going to um, feel the heat, okay? But in the endothermic reaction, something will become colder. Now, if we use a thermometer and test out your mixture or your surroundings, what you will notice is that in an exothermic reaction, the final temperature we record here will be greater than our initial temperature. And oppositely, in an endothermic reaction, your final temperature will be lower than your initial temperature. Alright, so let's start with the exothermic reaction first. In an exothermic reaction, since heat is being released to the surroundings, your energy is on the right side of the equation. So think about it this way. If x is equals to y plus 10, your x is of course greater than y because your y needs 10 to be equals to x. So in the same way, energy is actually the same on both sides, okay? But right now from this equation, from this reaction, we can see that the products have less energy than the reactants, okay? But since it has less energy, the products are more stable than reactants. Now if we translate it to an energy diagram, it should look like this. So in an exothermic reaction, your reactant's energy level would be higher. This is the energy level, so the reactants would be higher and the products would have lower energy. Okay, so if we write down an equation, okay, so this is a simple reaction where metal reacts with an acid to give a salt and hydrogen. So the delta H here, which we call the enthalpy change delta H, it is the amount of heat energy which is either released or absorbed in a chemical reaction, okay? So in this case, our delta H is giving us a negative sign. A negative sign is a sign that shows that the heat is being released to the surrounding, okay? So make sure that you don't confuse it as well. Alright, so the enthalpy change delta H, the unit for it is kilojoules per mole, and it's usually calculated as the energy of the products minus the energy of the reactants, but we will actually get to how to calculate them, okay, in a few seconds. And one thing that you should know here is that this negative value here, right, it is always looked at from the side of reactants. We will always talk about if heat is absorbed or released from the reactants. We do not actually need to think about the products at all, okay? So if this is negative, it means that heat energy is released, okay, from the reactants. All right, endothermic reaction, okay? In an endothermic reaction, if you can see here, the reactants will have less energy than products, okay? So let's just put it this way. The products is going to have more energy than reactants, meaning that in endothermic reaction, the products are less stable than reactants. That is why if we put it into a energy level diagram, we can see that the reactants will actually have lower energy while the products will have higher energy. So make sure that you know what the draft of this, because in exam they're going to ask you to draw this. Okay, your x-axis is the progress of the reaction, your y-axis is your energy. All right, so let's take a look at one of the equations, which is a thermal decomposition. So when we strongly heat calcium carbonate, it decomposes into calcium oxide and carbon dioxide. Here, the positive sign shows that heat is being absorbed. Okay, so as usual, your delta H is kilojoules per mole. It is the energy of products minus the energy of the reactants. All right. So if we want to calculate the total energy change or the enthalpy change, you need to remember this very important equation, which is this one. Q is equals to mc delta T. So your Q is the heat energy change, m is simply the mass. Now C is the specific heat capacity. Okay, so it is a constant value. So let's try to look at the definition here. Specific heat capacity is the amount of heat which we need to raise the temperature of 1 gram of a substance by 1 degree Celsius. So let's just try to put it in watts. So the specific heat capacity of water is 4.18 joule per gram per degree Celsius. Okay, so this is the unit for specific heat capacity. It means that we need 4.18 joules of energy or heat to raise the temperature of 1 gram of water by 1 degree Celsius, and the value for C is always going to be 4.18 if we are using water or water-based solution such as aqueous. Okay, and delta T is simply our temperature change. The unit of Q, as you learned from physics as well, is simply joule. All right, so another, if we know what is the Q formula, heat energy change formula, we need to know the molar enthalpy change. Okay, so the molar enthalpy change simply is the change in enthalpy when 1 mole of a particular reactant reacts. So it's just saying the delta H is heat energy change, which is your Q here, divided by the number of moles of a particular reactant, okay, of any reactant that you want to find out. But this will all become clear as we start to do a few calculation examples. Now, let's try to do one example here. So lithium oxide reacts with water to form lithium hydroxide as the only product. A scientist uses a calorimeter to measure the temperature change of the reaction. The volume of water used was 100 centimeter cube. So you should know here that 1 centimeter cube is actually equals to 1 gram. Okay, so he recorded the following changes. Complete the table giving all values to the nearest 0.1 degree Celsius. So when you do this chapter, it's important that you know how to read. Okay, you know how to read the thermometer. So they already give you the temperature before adding lithium oxide is 17.3. So after adding the lithium oxide should be, let's try to see here. Okay, it's this mark. All right, so let's try to do this together. Okay, so this is 25, so this is 26, 27, and 28. Okay, and how many lines do we have? 1, 2, 3, 4, 5. So if 5 lines are, let's say, 1 degree Celsius, how many lines do we have? 3 lines here. Okay, so 3 lines would be 3 divided by 5. Okay, so which should give us 0.6. Okay, so but it starts from 27, so our temperature here should be 27.6 degrees Celsius. Okay, all right, so let's just fill this in. 27.6 degrees Celsius. The temperature rise in degrees Celsius is, you simply subtract the before and after, so you should get around 27.6 minus 17.3, so around 10.3 degrees Celsius. Okay, all right, calculate the heat energy change in the reaction. So heat energy change, if you remember the equation, it is Q is equals to mc delta T. So your mass should be the mass of your water, which they give you here 100 centimeter cube. So it should be 100 grams multiplying with 4.2, which is your constant, and the change in temperature, which is 10.3. Alright, from here you should get 4,326. Okay, this would be joules. Alright, let's continue. Okay, so in another experiment, the scientists obtained these results. Calculate the molar enthalpy change in kilojoules per mole. Include a sign in your answer. So what's this given to you? You're giving the mass of lithium oxide. So and it's asking you to find the molar enthalpy change, right? Which is delta H. So the formula of delta H is your Q over your mole, right? So your Q is already given here, which is the heat energy change in joules is 5,210. So we need to find out what your mole is. So you're simply going to find mole from your mass, okay? So mole of lithium oxide would simply be the mass given to you divided by the molar mass, okay? All right, so let's do this. So the mass given to you is 1.75 gram, and the molar mass is, let's say it's lithium oxide, LiO. Okay, so if you find it, you should get 30 gram per moles. Okay, this is coming from your periodic table. All right, divided by 30, so you will get around 0.0058 mole. Alright, so you can actually substitute here. So your Q is how much? 5,210. But since we want this to be in kilojoules per mole, right? We need to change this joule into kilo. So this would be 5.21 kilojoule divided by 0.0058 mole, which would lead us to have 898 kilojoules per mole. All right, but since the question is asking you to include a sign in your answer, your sign should be what? It should be negative, okay? Because why? Your final temperature is greater than your initial temperature, okay? Your final temperature is 27.6, which is higher than your initial temperature 17.3, which means that this reaction is exothermic reaction. And that's why you need to put the negative sign here. All right. All right, so let's do another simple problem, okay? So show that the heat energy change Q to raise the temperature of 100 centimeter cube of water by 30 degrees Celsius is approximately this much. So this is a show that question. You're given the mass of water and the specific heat capacity of water. So we're simply going to use this Q is equals to mc delta T equation, where your mass is 100 centimeter cube. 1 centimeter cube is 1 gram. So 100 centimeter cube would be 100 grams. And your C would be 4.2. And your delta T is already mentioned here. They're going to raise the water by 30 degrees Celsius. So it is simply 30. Okay. So you're going to get 12600 joules. So you have to prove that it is approximately equal to 13 kilojoule. So this is going to be, let's say 1, 2, 3. So this is 12.6 kilojoules, which is approximately going to be equals to 13 kilojoules. The student burns 0.96 gram of methanol. Methanol is very similar to water in terms of energy change, okay? So they want you to find the molar enthalpy change delta H for the combustion of methanol. Include a sign in your answer. So let's just write down the general formula first, okay? So delta H is equals to Q over your mole, right? Mole of methanol. Okay, so you already got your Q here, so you only need to find mole. So your mole of methanol would be mass over your molar mass. Okay, so your mass is how much? 0.96 grams divided by your molar mass, which is already given in your question, 32 grams per mole. So you would get how much if you use your calculator? You'll get 0.03 mole. Alright, so we're going to substitute in this equation. So delta H is simply going to be 13 kilojoules divided by 0.03 moles, which will give you 13 divided by answer should give you 433 kilojoules per mole. And since this is a include a sign, right? And this is a what reaction? It is a combustion reaction as it is mentioned here. So we're going to put a negative sign since this is an exothermic reaction. Alright, so that is all for the part 1, and we're going to do some more in part 2 and part 3. Alright, see you guys next time. Bye.